All right, welcome back everyone to the deep dive. When we think about vitamins, we usually think about the foods we eat. But today we're going to be looking at how we get some of those vital vitamins through industrial production. And specifically, we're diving into how tiny organisms, microbes, are
Mhm.
being used to create vitamins in a way that's actually pretty sustainable.
Yeah.
So, based on the stuff we've been looking at, we're focusing on two key vitamins today. Vitamin B12, also known as cobalamin,
Mhm.
and then vitamin B2, or riboflavin. So, are you ready to kind of get into how microbial fermentation is used to create these essential nutrients?
Yeah, I think it's a fascinating topic, and I think it's something that most people probably don't even really think about.
Yeah.
They just assume if they need a vitamin, they're going to get it from a pill or from the food they eat.
Right.
But there's a whole world of industrial production behind that.
Yeah, and it's not just like squeezing oranges to get your vitamin C. I mean, this is serious science, right?
Exactly.
Okay, so let's start with vitamin B12, cobalamin. We've seen in our research that it's produced industrially using, as we've been saying, microbial fermentation. Now, a lot of us, when we hear the word fermentation, we think of things like making beer or yogurt. So, is this basically the same kind of process, but for B12?
Yeah, it's a similar concept. I mean, you're essentially harnessing the power of microorganisms to transform substances. So, in the case of B12, you have these specific bacteria, and they're cultivated in these large vats, right, under controlled conditions. And as part of their natural metabolic processes, they actually produce vitamin B12.
Oh, wow. So it's like these bacteria are little B12 factories.
Exactly. And that's what makes this so interesting, right? Because it's not like we're trying to extract B12 from something.
Right, like digging it out of the ground.
Yeah, instead we're kind of creating an environment where these bacteria thrive and naturally produce what we need.
Okay, so if we think about it, B12 is typically found in animal products, right?
Right, primarily.
So if you're not getting enough from your diet and you're maybe not eating a lot of meat or dairy, this is where this industrial production really comes into play.
Exactly. And I think what's interesting about this is that it also kind of offers a more sustainable option, right? You're not dealing with, the land use and the resources associated with raising livestock.
Right, so it's like a more direct route.
Exactly. You're essentially, like you said, brewing B12 in a very controlled way.
That's a good way to put it. Now, our sources also point to vitamin B2, riboflavin, as another example of a vitamin that's made through this microbial fermentation. What can you tell us about that process?
Well, it's similar in principle, right? We're
Hmm.
still using microbial fermentation. However, and this is what I find so fascinating, is that we're using different microorganisms. So for B12, you might have one type of bacteria, but for riboflavin, you might be using a completely different type of microbe, maybe even a fungus.
Oh, wow. So it's not a one-size-fits-all.
Exactly. And that speaks to the versatility of this whole approach.
Yeah, that's really interesting. It's like we're tapping into this huge, diverse world of microbes,
Absolutely.
and each one has its own special skill set.
Exactly.
Yeah. Now, I think it's important for us to also kind of step back for a moment and talk about why we even need these vitamins in the first place. I mean, we're going through all this effort to produce them.
Yeah, that's a fundamental point. So, vitamins, as our sources point out, are organic micronutrients. They're these compounds that our bodies need to function properly, but we can't produce enough of them on our own.
Right. We have to get them from outside sources.
Exactly. So, B12 and B2 are involved in all sorts of essential processes like energy production, nerve function, keeping your skin healthy, and even maintaining good vision.
And this is where I think the importance of having reliable ways to produce them really comes in.
Absolutely. I mean, imagine if we only relied on getting these vitamins from our food. That's not always practical or accessible for everyone.
Right. And this is where this idea of microbial fermentation as a sustainable approach really makes you think. I mean, it's not just about meeting the demand. It's about doing it in a way that's good for the planet.
Exactly. I mean, think about the alternatives, right? You could try to synthesize these vitamins chemically, but that can be complex and resource intensive.
Right. Or you could try to extract them from natural sources, but that could have limitations in terms of yield and sustainability.
Exactly. And, I think this also raises some interesting questions about the future. If we can harness microbes to make vitamins, what else could we potentially produce using these kinds of biotechnological approaches?
That's a great point. I mean, could we be looking at a future where we're producing all sorts of essential nutrients, medicines, even materials using microbes?
It's definitely within the realm of possibility.
That's pretty mind-blowing. So to sum it all up, I think the key takeaway here is that Microbial fermentation isn't just some sci-fi concept. It's a real, effective method for producing essential vitamins, and it's actually happening right now on an industrial scale.
Yeah. And, as we move forward, I think it's really important to keep exploring these kinds of sustainable solutions.
Exactly. It makes you think about all the potential that's out there waiting to be unlocked. And on that note, I think that's a good place to wrap up for today. We've covered a lot of ground,
We have.
and I think it's definitely given us all something to ponder. So until next time, keep exploring, keep questioning, and keep diving deep.
Yeah. See y'all next time.
Bye.
Yeah.